All right, today we are doing lesson 4, unit rate and unit price. So we have a few new vocabulary terms we have to look at. The first is rate. A rate is a ratio comparing two quantities of different kinds of units. Okay, so before when we were looking at just regular ratios, we were looking at things like comparing cats to dogs, which are both types of animals, or chocolate donuts to pumpkin donuts. Now we're going to be looking at different kinds of units, okay? A unit rate is a rate that describes how much of something there is per 1 unit. Okay, so that prefix UNI tells us that we're looking at something that has to do with one. So think of like a unicorn with one horn or a unicycle with one wheel, okay? So this is the same as a proportion word problem, except you are always solving for 1 unit. Okay, so you're always going to have a 1 somewhere in your end result. Okay? Then we have unit price. So again, unit, we're looking at the cost per 1 unit. It's the same as unit rate, except for we're talking about money. Okay, so again, it's the same as a proportion word problem, except you are always solving for the cost of 1 item being sold. Okay, if you divide instead of using a proportion, it's really important that money always goes on top. We're going to teach you to solve them using a proportion because you're less likely to make mistakes that way. Okay, so for problem 1, we have Jennifer picked 84 apples in 7 minutes. How many apples did she pick per minute? Okay, so we're going to start the same way as our proportion word problem. We're going to look for our units. Okay, so I have 84 apples, so that's going to be one of my units, apples. And I have 7 minutes. So my other unit is going to be minutes. Okay, I know that my initial ratio, Jennifer picked 84 apples in 7 minutes. My question is, how many apples, so that's what I'm looking for, I don't know how many apples, so that's my variable, did she pick per minute? When you see per minute or per hour or per gallon, that means we're looking for 1. So you might not actually see the number 1. It's not going to maybe say for every 1 minute, but if you see per whatever, you're looking for 1. Okay, so I want to know how many she can pick per minute or in 1 minute. Okay, I'm going to set this up the exact same way, same steps. I'm going to look at my diagonals. I'm going to multiply the numbers that are across from each other, or diagonal from each other. So 84 times 1, and that equals 84. And then I'm going to divide by the number that's across from my variable, which is 7. Okay, same steps. 84 divided by 7 equals 12. Since these are word problems, you're going to have units in your answer. Make sure you're using the correct units. Okay, I was looking for the number of apples. So it's 12 apples. And since this is a unit rate problem, we're going to write this as 12 apples per minute. That is the rate she is picking apples at, 12 apples per minute. Okay? Example 2, Sydney read 50 pages in 40 minutes. How many pages per minute can she read? Okay, so I have my 2 units. I have pages and I have minutes. Okay, my initial ratio, Sydney can read 50 pages in 40 minutes. My question is, how many pages, so I don't know how many, that's going to be my variable, per minute can she read? So remember, per minute means for every 1 minute. Okay, so I want to know in 1 minute, how many pages can she read? Again, same setup as our proportion word problems. I'm going to highlight my diagonals. I'm going to multiply the numbers that are across from each other. 50 times 1, and that equals 50. And then I'm going to divide by my number across from my variable, which is 40. 50 divided by 40 equals 1.25. And I was looking for the number of pages, so she can read 1.25 pages per minute. Okay, example 3. On 9 gallons of gas, Daniel traveled 261 miles. How many miles did he travel per gallon? Okay, so I'm going to look for my 2 units. I have gallons and I have miles. Okay, so 9 gallons, 261 miles is my initial ratio. I want to know how many miles, so I don't know the number of miles, he can travel per gallon. Okay, so on 1 gallon of gas, how many miles can he travel? I'm going to highlight. Right, I'm going to start by multiplying the numbers that are across from each other. So I have 261 times 1, which equals 261. And then I'm going to divide by my number that's across from my variable, which is 9. And 261 divided by 9 is 29. Okay, again, I was looking for the number of miles, so 29 miles per gallon. Okay, so Daniel can travel 29 miles per gallon of gas. All right, go ahead and flip that over to example 4. Last week, Eric worked 18 hours and earned $225. How much was he paid per hour? Okay, so now we're talking about money, so we're looking at unit price. Okay, same setup, even though it's money, and it's just called something different. Okay, so again, we're looking for our 2 units. We have Eric worked 18 hours, so my first unit is going to be hours. He earned $225, so oops. My second unit is going to be dollars, okay? My initial ratio, 18 hours for $225, okay? I want to know how much he was paid, so I don't know how much money he made. How much was he paid per hour? Again, per anything means I'm looking for 1. Okay, so how much did he get paid for 1 hour of work? Exact same setup. I'm going to highlight my diagonals. I'm going to start by multiplying my numbers that are across from each other. 225 times 1 equals 225. And then I'm going to divide by my number that's across from my variable, divided by 18 equals, and you're going to get 12.5. When we're talking about money, we always need to have something in the hundredths place. So it's $12.50 per hour. Okay, so that's how much he made in 1 hour. Example 5, Ashley bought 6 books for $32.16. How much did it cost per book? I'm going to look for my unit. So I have 6 books. So my first unit is going to be books. And $32.16. So my second unit is going to be money. Okay? My initial ratio for 6 books, so I have 6 on the top and 32.16, $32.16 on the bottom is my initial ratio. I want to know how much it cost per book. Okay, so I don't know what the price was. I'm looking per book, so 1 book. Okay. Going to highlight my diagonals. Okay, and I'm going to multiply. So 32 and 1600ths times 1 equals 32 1600ths. I'm going to divide by my number that's across from the variable. So divided by 6. And that's going to get me $5.36 per book. Okay, so each book costs $5.36. Okay? The last thing we are going to do is compare unit rates. Okay, so a good real-world example of using unit rates or unit prices is to find the lowest cost per pound, per item, because a lot of times prices are just given, you can get, like in this table, 6 apples for 5 pounds, but maybe another store has 7 apples, or I'm sorry, $6 for 5 pounds, but maybe another store has, $7 for 5.5 pounds, and it's hard to tell which is the better deal. So this is a good real-world application, okay? So it says, the following table shows the cost for 4 fruits, or 3 fruits. Which type of fruit has the lowest cost per pound? Okay, so we're going to look at all of them. So I'm going to start with apples. I'm going to put an A here so I know I'm looking at apples. I have the cost in one column, so I'm going to put the cost on the top, and then the pounds, okay? Or you can abbreviate it pounds, okay? So for apples, it costs $6 for 5 pounds, okay? So if you want to look at it this way, I have dollars and I have pounds. Okay, so my first initial ratio for apples, I have 6 and 5. Okay, I want to know the lowest cost per pound. Okay, so with 1 pound, how much would it cost? Okay, exact same setup. I'm going to highlight. I am going to multiply my numbers that are across from each other. 6 times 1 equals 6. I'm going to divide by the number across from the variable, which is 5, okay, and that equals $1.20, okay, so apples are $1.20 per pound. I have bananas next. I'm going to put price on the top, pounds on the bottom, $4 for 5 pounds. I want to know how much it's going to cost for 1 pound. So I'm going to multiply 4 times 1 equals 4, and then I'm going to divide by 5, which equals 80 cents, 0.8. I'm going to add that 0 for money. Now I'm going to look at peaches. Okay, I'm going to put the money at the top, pounds on the bottom. I can get for $5, I can get 4 pounds of peaches. Okay, I want to know how much it would cost for just 1 pound of peaches. Okay, so I'm going to multiply 5 times 1, which equals 5. And then I'm going to divide by 4, which equals 1.25. Okay, so now I'm going to look which one of these is the lowest, which one is the cheapest. $1.20 for 1 pound, 80 cents for 1 pound, or $1.25 per 1 pound. 80 cents is the cheapest, which means the type of fruit that has the lowest cost per pound or the lowest unit price would be bananas. Okay, go ahead and do the you try. In 30 minutes, the Australian dragonfly can travel 18 miles. How far can it travel per minute?